Hello, my name is Ajay Dholakia. I'm back to continue our conversations in this very interesting field of generative AI. In the past couple of sessions, we talked about what are models, and we looked at neural networks as one type of models, but then we zoomed in on large language models and even a more general category of foundation models. These are the types of models that are being used within generative AI. The reason they are important is they are pre-trained using lots of data once or at one point in time, and from then on they are ready and available for use. So we defined some of those differences in that first session. In the second session, where we talked about preparing these models, we went through the data prep, the training step, and all what is needed to be able to do that. And then we focused on inferencing, or the use of those pre-trained models. We talked about a couple of techniques that are used to get additional performance or capability out of them. One of them was RAG, R-A-G, retrieval augmented generation. The other was fine tuning. That was the way we can enhance the output coming from the models. And we sort of left it at that. Today, in this third session, what we want to get into is using the models in order to get more effective performance or output from them. So typical usage scenario would be that you have the model. I'm calling them LLM for large language models or foundation models. Users typically supply a query, and you get a response that is generated by the model. This would be one of the usage modalities or scenarios where we have a Q&A system. There might even be another use case where it's summarization. So you supply some document and then the model generates a summary. So there is some sort of an input and an output. In the previous session, we even looked at input could be text or images, and output could be text or images. So today, we want to get into how to actually go about improving the effectiveness or the performance of what the model is producing as output. So that's our goal. How do we measure this effectiveness or this performance? I would say we sort of have to define some criteria, and a few ideas are noted here. One is accuracy. How accurate is the output, the answer that's being generated by the model in response to your question or a user's query? Is it relevant in terms of the domain or the context? Is it traceable in the sense that you are able to pinpoint where that answer came from, which document, or and so on? So a couple of things to just clarify. When we say domain here, we are talking, let's say, think of a particular industry. So medical or banking or finance, insurance, legal, what have you, right? So that's what we mean by domain here. So when you ask a question, typically a question is coming with an assumption about some sort of a domain or a context or an industry. So that context is important as well. And one of the key things that is crucial for the models is providing the right context. So this is really where a number of techniques have emerged that people talk about. So let's say you can think about them in this flow here. One is just the raw LLM. It was pre-trained, it's available. You go ask some questions, you get the answers, and you get what you get. Maybe they are accurate, maybe they are somewhat accurate, maybe they are outright what we call hallucinations. So you hear words like hallucinations is when the output is a plausible sentence, so it's proper in the language that it's being generated in, but inaccurate, right? That's what we don't want happening. So one way to get a better response is what you would see or have heard people talk about is called prompt engineering, right? And what is that? You create in your query itself, you supply some tokens or terms that are hinting at the prompt or hinting at the context, right? So the context is, let's say we are talking about a big sporting event. So your context might be which sport you are talking about. Let's say some event was held, so you are saying which city was the event held in. It was held in a particular year. So all these little hints may help the model zoom in on creating a more accurate response. That sounds like magic, but we'll sort of try to break it down a little bit and see how that helps. So you ask a question to the LLM, and let's say there was no other help provided, versus you bake it in. And I'm going to pick the example of Super Bowl, which is the American football championship that's typically held at the beginning of the year. And in 2023, let's say the Super Bowl was held in Las Vegas, and you ask a question, what was the color of the stadium? And just using that as an example, if I ask the question to be, what was the color of the stadium for last year's Super Bowl, I've given some hints by mentioning Super Bowl. It hints at the sport. Last year is hinting at the year, but I didn't give any prompt about the city. I could have formed a question saying, what is the color of the stadium in Las Vegas where the Super Bowl final was held last year? So now I'm giving a better prompt, or rather more context-rich prompt, right? That's prompt engineering. So let me say that the raw LLM sort of sits here, and then we improve a little bit by doing better prompt engineering, right? In this axis, what I'm trying to show is there are additional ways of helping the model. So if we go up this dimension, the y-axis, we are aiding the model. There is one way to do that, and this is what we talked about in the session last time, retrieval augmented generation of responses, right? So it's commonly called out as RAG. So you hear a lot people saying, is your LLM assisted by a RAG capability? And basically what that is doing is, before the query is sent, there may be some context documents, or which could also be images, uploaded, let's say, in a vector database, they call it, because it's a very dense. And then instead of directly feeding the query, you send it to this, and then the query comes from picking up the right context that was supplied in the documents that you wanted it to zoom in on. So that's RAG, or retrieval augmented generation. What are the pros of doing RAG? Well, tomorrow you can supply a different context. Today I am focusing on banking, tomorrow I am going for legal, third day I am going for medical. By changing the documents that I provide as part of this vector database, I could still be using the same LLM, but make it focused on a specific industry by changing that context. On the x-axis here, I'm saying enhancing or reinforcing the model. So in this case, we are aiding the model. We are not changing it. We are just aiding it, right, as we see over there. The other popular technique is what we call fine tuning. So fine tuning means we are doing some additional training, adjusting of the parameter weights. So the model actually is transforming or is getting better tuned, so to speak, by taking the context information and doing some more training with it. So in this case, a good analogy would be that the model itself changed and the context gets baked in, if I use that term, into the model weights and parameters itself. So this is the fine tuning dimension. That's another way we can improve the context. Lo and behold, there is a best of both world retrieval augmented fine tuning. So what we call RAFT has emerged recently, and that sits over here where you do a bit of both. So going back to why would you do one versus the other, as I said, the RAG has the advantage that you could change out the context and use the same LLM. But let's say if you discover that I'm always going to be serving the medical industry, so my domain or the industry is fixed, I might as well evolve or enhance the model by baking in that context in the model parameters themselves. So that's when you go down the fine tuning, you remove an additional step. Your LLM has changed, but now it's changed to contain that context from within that industry. Okay, is that a good thing or a bad thing? It depends on your use case. Typically what happens is as time goes on, new information becomes available. So you want to be able to do a bit of both, and this is where the RAFT technique has come in and is finding some popularity. It's still an ongoing field of research. But one of the ways that we can think about this is, well, if I have all these options, how many? 1, 2, 3, 4, 5 of them. How do I evaluate? So there are some specific data sets that we could use. I think there is one called PubMed QA, there's another one from Hugging Face, and then there are others, Tensor Hub and so on, that are standard set of queries and response pairs where you can stack up one technique versus the other and get a sense of how the accuracy improves. The flip side is when the accuracy improves, actually hallucinations go down, right? When the accuracy goes up. You could also look at domain relevance. Am I getting answers that are in domain? They are completing the task by staying within that domain. So there are some of those criteria. And we go through all this, hopefully, with the end goal that we want to be able to right size the system infrastructure, right? So by that I mean not just the hardware, yes, the hardware, but also, so I'm going to put it hardware plus software for the type of task that a customer is looking to do. So hopefully you're following along, and my takeaway to you out of this session is that when you understand where the customer is looking to go in terms of their use of generative AI based on a large language model or a foundation model, it may help you right size the system, the hardware and software that we offer them up as Lenovo to help solve their problem, their business challenge. We could go one way if there is going to be main focus will be on RAG assisted. We could go another way if the model itself is going to be fine tuned. If they are looking for hardware and software to do the fine tuning, that's certainly something we can help with. Or is there a best of both world type configuration that is needed that helps them address on an ongoing basis a combination of the two? So this is where we can help our customers get to the right solution for their needs in this space of generative AI. Hopefully this was useful and interesting to you. Stay tuned. In a future session, we will get into a little more detail about this, evaluating this performance of these different techniques and discussing some of the pros and cons. Thank you.